cosmos, prepare to embark on a journey through the cataclysmic history of Venus. Delve into the depths of its enigmatic nature as we unravel its physical characteristics, peculiar axial rotation and orbital motion. Learn about the unique atmospheric conditions and the powerful greenhouse effect that makes Venus the hottest planet in the solar system. Venture to the surface of Venus and behold the scorching landscape, unveiling the fascinating features that define its terrain. Through the lens of exploration, we'll uncover the remarkable tales of cosmic missions that have dared to venture close to Earth's neighboring world. Sit back, relax, and enjoy the show. Venus, the second planet in the solar system, and the closest planet to Earth. Venus is named after the Roman goddess of beauty and love and has been known to humanity since prehistoric times. It is the brightest object in the sky after the sun and the moon. It can be observed with the naked eye before sunrise or after sunset. In ancient Greece, as in other ancient cultures, it was believed to be two separate objects, and thus it was given two different names. Telescope observations from Earth show that Venus goes through different phases, similar to the Moon, as it is in a closer orbit to our star. The phases of Venus were first identified in the early 17th century by Galileo Galilei. They are an undeniable confirmation of the heliocentric model of the solar system, proposed a century earlier by Nicholas Copernicus. When it is close to Earth, Venus appears larger, and it can be seen in the shape of a crescent. As it moves away from us, its disk gradually fills out, and its apparent size decreases. In its full phase, Venus is on the opposite side of the Sun and cannot be observed due to the much higher luminosity of our star. The passage of Venus across the line connecting the Earth and the Sun is called a transit, during which it obscures a part of the solar disk. This phenomenon occurs relatively rarely because Venus's orbit is inclined by more than 3 degrees relative to our planet's orbit, and its next passage is expected in 2117. In the 18th century, the transit of Venus was used to determine the size of the planet, as well as its distance from the Sun. The results obtained have a deviation of only 3 to 4% compared to modern data. In terms of size, Venus is almost as big as Earth. Its diameter is only 638 kilometers smaller and has a mass of approximately 82% of Earth's. The shape of Venus is very close to a sphere, with no flattening at the poles and no bulging at the equator as it rotates extremely slowly on its axis. Unlike most planets in the solar system, its axial rotation is in a retrograde or clockwise direction and completes one rotation in 243 Earth days. It is assumed that this is due to a collision with another massive celestial body billions of years ago. The impact was extremely powerful and either changed Venus's rotational direction or completely flipped its axis. In contrast to the elliptical orbits of most planets, Venus's orbit is nearly circular. It is located approximately 108 million kilometers from our star, which is equivalent to 0.72 astronomical units. The planet completes one orbit in almost 225 Earth days, i.e. 18 days faster than its rotation period. As a consequence of Venus's slow rotation in the opposite direction, a day lasts about 117 Earth days. Thus, in a Venusian year, there are on average 2 sunrises and 2 sunsets, and the Sun moves from west to east. The obliquity, or the axial tilt of the planet, is slightly less than 3 degrees. Therefore, seasonal temperature variations on the surface are insignificant. Given Venus's similar size to Earth, people in the recent past thought that it had conditions suitable for supporting life. Further observations have revealed that these assumptions were the complete opposite of reality. The planet does have an atmosphere, but it is exceptionally dense and is composed of 96.5% carbon dioxide, 3.5% nitrogen, and traces of other gases, like sulfur dioxide. The high concentration of carbon dioxide is responsible for a strong greenhouse effect, which prevents the atmosphere from radiating enough heat into space. That makes Venus the hottest planet in the solar system. As a result of the greenhouse effect, the surface temperature reaches over 460 degrees Celsius. It is presumed that in the distant past, Venus's conditions were Earth-like and the planet probably had liquid water. Over time, it evaporated and was carried away into space by the solar wind. Atmospheric pressure on the surface is 90 times higher than on Earth and is equivalent to the pressure at a depth of nearly 1 kilometer in Earth's oceans. The atmosphere of Venus is divided into several layers of different densities. The bottom layer is the troposphere, which extends to a height of about 65 kilometers. It has the highest density and contains 99% of the atmospheric mass. The surface pressure is so great that carbon dioxide is in the form of a supercritical fluid. This is a state of matter between liquid and gas, and Venus is effectively covered by an ocean of semi-liquid gas. The supercritical fluid is characterized by high thermal conductivity and is accountable for equalizing the temperature differences between the day and night sides of the planet. Venus's surface winds are weaker than Earth's and have speeds of a few kilometers per hour. Due to the high atmospheric density, they are capable of displacing sediments and even small rocks and are accountable for the slow process of physical erosion. As altitude increases, the density of the troposphere drops, and wind velocity reaches up to 360 kilometers per hour. That leads to the so-called superrotation, where the atmosphere revolves up to 60 times faster than the planet itself. Superrotation is most pronounced in the mid-latitudes and less so in the equatorial regions. Approaching the poles, the speed of air masses gradually decreases. Venusian winds are driven by convection processes that transfer heat from the equatorial to the polar regions. Around the poles, giant anticyclones form, which are 4 times larger than those on Earth. Similar anticyclones can be observed in Antarctica, but unlike them, those on Venus are double, and the cloud cover moves in an S-shaped pattern between the two vortices. At altitude slightly above 50 kilometers from the surface, Venus's atmospheric pressure is close to Earth's, with temperatures ranging from 30 to 70 degrees Celsius. That is the only place in the solar system with atmospheric conditions that resemble those on our planet. Between 40 and 60 kilometers in altitude lies a cloud cover composed mainly of sulfur dioxide and droplets of sulfuric acid. The clouds completely envelop the planet and contribute to its high reflectivity, known as albedo. Venus's atmosphere reflects more than 75% of the sunlight, more than any other planet in the solar system. The precipitation on Venus is acidic, but because of the high temperature, it does not reach the surface. Instead, it evaporates at an altitude of about 25 kilometers. It was confirmed that electric charges are generated in the clouds of the planet, leading to the formation of lightning. The mesosphere is situated at an altitude of 65 to 95 kilometers, and on its upper boundary lies a very thin ozone layer. Beyond the mesosphere begins the thermosphere, which extends to about 120 kilometers. The lowest temperature on the planet was recorded on the night side of the thermosphere, at -173 degrees Celsius. The ionosphere is the outermost layer of the atmosphere, extending up to 250 kilometers from the surface. It contains highly rarefied gases, but the ionization levels are high only on its daytime side. Unlike Earth, Venus does not have a magnetic field. Even so, it possesses a weak magnetosphere, located at an altitude between 250 and 300 kilometers. It results from the interaction between the Sun's magnetic field lines and the upper layers of the ionosphere. That induces a local magnetic field, which is unable to prevent the escape of gases caused by the solar wind. On the side opposite to the Sun, a magnetic tail forms, extending up to 5 times the planet's diameter. It contains ionized helium, hydrogen, and oxygen, indicating an ongoing process of water loss. Besides having a distinctive atmosphere, Venus stands out with its unique surface features. The planet's terrain is predominantly flat and composed of volcanic rocks. It consists of valleys, plains, and high plateaus, with average variations in altitude of only a few kilometers. The two large high plateaus resembling continents are located in the northern and southern hemispheres. The northern continent is called Ishtar Terra, after the Babylonian goddess of love. It is almost the size of Australia, and there is located the highest mountain on the planet, Maxwell Montes. Rising to an elevation of 11 kilometers, Maxwell Montes is named after James Clerk Maxwell, the father of electromagnetic theory. The continent in the southern hemisphere is larger and comparable in size to South America, and is called Aphrodite Terra. On the peaks of Venus, at altitudes above 2,600 meters, there is a light coating resembling snow. In this case, it is not water ice crystals, but condensed vapors of lead and bismuth sulfides. The surface of Venus is considerably younger than that of the other terrestrial planets and is about 500 million years old. That is due to a global volcanic process, which has entirely covered its older crust. A prominent feature is an enormous system of over 200 channels of solidified lava, concentrated mainly in the equatorial regions. The biggest channel measures approximately 6,800 kilometers in length and is up to 300 kilometers wide. The planet's volcanic activity is the primary factor shaping its topography. Venus has nearly 1,100 volcanoes with diameters exceeding 20 kilometers and numerous smaller ones. There are also more than 160 giant volcanoes wider than 100 kilometers. They have been preserved for millions of years because the planet has no tectonic plates, and its surface is not subject to intense erosion. For the same reasons, about 1,000 asteroid impact craters are still intact on the surface. They are distributed fairly evenly and range in size from a few kilometers to several hundred kilometers across. The largest one is located north of Aphrodite Terra and has a diameter of 270 kilometers. An intriguing phenomenon is that Venus lacks craters less than 2 kilometers in size. Small bodies that enter its dense atmosphere burn up and do not reach the surface. Therefore, most craters have diameters exceeding 30 kilometers. Although with a very different surface, Venus is similar to Earth in terms, at a certain point, it triggers the collapse of the lithosphere and a global renewal of the planetary crust. The mantle is composed of molten silicate rocks and has a depth of about 2,800 kilometers. The dense crust does not allow the mantle to cool effectively, which is the reason for the unusual volcanic activity on Venus. It is unclear whether the core is in a liquid or a solid state. That question should be answered by future scientific missions. Because of its proximity to Earth, Venus is one of the most studied bodies in the solar system. Spacecraft exploration began in the early 1960s with the Soviet Union's Venera program. Venera 1 was launched in 1961 and was the first probe aimed at another planet. By the end of 1962, NASA's Mariner 2 approached Venus at about 35,000 kilometers and gathered data about its atmosphere. In the 1970s, several Soviet probes made soft landings on Venus, sending back images from the surface and examining rock samples. The following Soviet program was named Vega, and in 1985 Vega 1 and Vega 2 were launched, which included landers and aerostats. In 1990, NASA's Magellan mission entered orbit around Venus. It mapped 98% of the surface and analyzed the planet's gravitational and magnetic fields. The European Space Agency joined the research efforts in 2006 with the Venus Express orbiter. It was designed for a long-term study of the atmosphere, and its mission lasted nearly 8 years. The Japanese Space Agency, JAXA, launched a similar mission known as Venus Climate Orbiter, which entered orbit in 2015 and continues to operate to this day. Over the past 60 years, more than 40 spacecraft have reached Venus. The information obtained from those missions provides a valuable example of the irreversible consequences of the greenhouse effect. It is a reminder that fighting climate change on Earth requires collective efforts from all of humanity to preserve the only habitable planet in the known cosmos.